Hello everyone, welcome back. My name is Mr. Cobalt, and in this video I'm going to go over a second problem regarding quantum numbers. First I want to point out a little bit of mathematical expressions or relationships that will help you remember a couple of things. I think this is the most important thing to remember, but there is some cool mathematical relationships that will help you as well, I think. Um, so if you know what n equals 4, what the n principal quantum number is, the principal energy level, energy quantum number is, then you can figure out at least how many of each of these types you're going to have, and you can also figure out the total number of um, orbitals you'll have at this principal energy level. So if, for example, n equals 4, then I showed before that the number of your principal energy level will give you the number of your subshells, the different types of orbitals that you will have. So you'll have, here it says 4, so you should have 4 different subshells or different sublevels or different types of orbitals or names of orbitals, right? So you have 1, 2, 3, 4. Now, what about the total number of orbitals itself at this energy level? Well, you'll find that you can do it this way, and this is I think the best way in terms of showing your understanding. But if you just want to give the number, or if you're asked to just find the number of the total number of orbitals at a particular energy level, then you can count them up, right? So you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, which is 16. But do you notice a relationship between 4 and 16? That's right. So 4 is the square. So 16 is the square of 4. So n squared will give you the total number of orbitals at your energy level, right? Now, one of the things that we're going to learn later on is that each orbital can hold a maximum of 2 electrons. So if you wanted to know what the total number of electrons at an energy level is, then if this gives you the total number of orbitals, and each orbital can hold 2 electrons, then the total number of electrons would be 2 times n squared. So that's going to give you the total number of electrons at this energy level. So it's always at the energy level. So I just wanted to show that that we have these relationships here that you can remember. But I think knowing this is the best way, because it shows more understanding of where these numbers are coming from and why they work. Okay, so problem number 2 says list the quantum numbers associated with all of the 5D orbitals. Okay, so what are all the quantum numbers? So 5D, but the 5 in front of the D represents the n quantum number, the principal energy quantum number. So that is n equals 5. So that tells you n equals 5. And then we're only interested in the d orbitals, right? So that would be, so if we write out our L values, so we're going to go from 0 to n minus 1, which is 4. So that's give you 0, L equals 1, and then L equals 2, and then L equals 3, and then L equals 4. So this is going to be your S, your P, your D, your F, and then L equals 4, we'll call this G. So that's going to be G. We're interested in only the D. So we're interested in this here. So then the question is, what are the quantum numbers associated with all of the 5d orbitals? Well, that's going to be n equals 5, right? That's 1. And since we're interested in the d, it's going to be L equals 2. That's another one. And then what about the m sub L values? So the m sub L values are going to be equal to from -2 to +2, including 0. So -2, -1, 0, 1, 2. So all of these are quantum numbers that are associated with the 5d orbitals. So we have energy level number 5, so n equals 5, principal quantum number level, principal energy level. Then we have the sub level, which is L equals 2, which gives us the name of our orbitals. So we're talking about d orbitals. And this tells us how many d orbitals we have. So we have 5 d orbitals. The other principal quantum number that we can't forget is also the spin, right? So what quantum numbers are associated with the 5d orbitals? Again, there is spin, but those are referring to the electrons, not the orbitals. So the electrons are going to have a quantum spin number of negative or positive 1/2. So that'll come up later when we talk about electrons. Okay, so these are the quantum numbers associated with the 5d orbitals. And how many 5d orbitals exist? Well, that's going to be your m sub L values. So we have 1, 2, 3, 4, 5. So we have 5d orbitals. We always have 5d orbitals. We're not going to have less than 5d orbitals. We're not going to have more than 5d orbitals, right? So no matter what energy level you're at, if it's at n equals 3, n equals 4, 5, 6, 7, whatever, if we're talking about d orbitals at that level, at that energy level, it's always going to be 5. So the number of orbitals does not change with the sublevel. So if you have an s orbital, you're going to have only one of them. If you are in the p subshell, you're always going to have 3 p orbitals. If you're at the d subshell sublevel, then you're going to have 5d orbitals. If you're at the f subshell, you're going to have 7 f orbitals. Okay, so and then so on. If you have g, like if we're at g, then we would add 2 new orbitals to 7. It will give us 9. So we would expect to have 9g orbitals at L equals 4, and then so on. So that's how you answer these 2 questions. I hope you found this helpful. I hope it's clear, and if you like this video, share this video with your friends, hit the notification bell, subscribe to the channel, put a comment in the comment section and let me know what you think, and if you have any more questions or anything that you want me to cover, just let me know. And thanks for joining me, and I'll see you next time.